Hi, in this video we're going to talk about reaction mechanisms. So up to this point we have been assuming that reactants are made into products in one single step. But the reality is they're not generally one-step processes. So what is a reaction mechanism? It is the steps needed for the overall reaction to occur. Each individual step is called an elementary step. Now, for example, A plus B makes C. C plus D makes E. And reactants and products will cancel. So this is actually A plus B plus D makes E. And out of the two steps, one step will generally be slower than the other one. So let's say this is a slow step and this is a fast step. A reaction cannot occur any faster than the slowest step. Slow step is also known as the rate determining step. And the rate law for the slow step must match the rate law for the overall reaction. So this is the overall reaction. But what is the rate law for the overall reaction? It is not rate equals K times A plus times B times D. It is in fact what the slow step is. So the rate law for this one will be rate is equal to K times the concentration of A times the concentration of B. Now if there's 2A or 2B, it's basically A plus A, right? So instead of writing 2A, you can think of it as A plus A, which is 2A. And 2A is basically multiplying over here another A, right? And then you can rewrite this as K times A squared times B. But that is just if there is 2A. But in this case, we don't. So don't worry about that. So the key point here is to know that the slow point is what determines the rate law for the overall reaction. So for example, if we have rate is equal to, let's say, K times A times B squared, and then you have two equations, A plus B, 2 moles of B makes C plus D, and then D plus E makes F. And asks you which one is slower and which one is faster. Well, now in this case, you obviously know that this one is slower, because the overall rate law shows you there's 1A and 2B's in the elementary step. So and the slower one will determine the overall rate. So this elementary step is the slower one, which determines the overall rate law. The rate law for the slower elementary step is the rate law for the overall reaction. Now, what if the slow step is not the first step? Like for the past two examples, we'll be saying that the slow step is the first step. Now, what if it's not? So let's look at a real example over here. We have 2NO makes N2O2 gas, and N2O2 gas plus O2 gas makes 2NO2. Now we're given that this is a fast step and this is a slow step. And because it is a slow step, we can say rate is equal to slow step, right? K times N2O2 times O2. But let's first take a look at the original reaction, overall reaction. All right, the overall reaction will be NO plus O2 makes 2NO2. If this is our rate, it's not even part. N2O2 is not even part of the overall reaction. It is made from our NO. So this cannot be our overall reaction. We need to do an extra step. Now, if you notice here, the first step is in equilibrium. So what does that mean? That means the N2O2 can freely exchange with the 2NO. So rate, we have rate, our slow step rate is equal to K times N2O2 times O2. But N2O2 is also equals to 2NO. So we can replace this N2O2 with K times NO squared, because there's a 2 in the front, times O2. And this will be our rate law for the overall reaction. And it is not just simply a slow step. We have to replace the N2O2 from what is producing it, which is 2NO. And that's it. This reaction is a second order with respect to NO, and first order with respect to O2. So it's an overall third order reaction. Remember, overall is just the two combined. So it's a third order reaction. So before I end the video, I want to talk about intermediates and catalyst. Intermediate is a substance that is created and then immediately used up again. A catalyst is something that is a reactant and a product in the end. I'm going to show an example here. So let's say we have A plus B makes C plus D. And we also have A plus D makes E. In this case, D is created from A plus B and then immediately used up again in the second step to form E. So this is when D is an intermediate. It is created and used up again. A catalyst, on the other hand, let's say we have A plus B makes C plus D. Then our second step is A plus D makes C plus E plus B. Now, as you can see here, D is intermediate because it is used and produced. But we also have B here, that is both a reactant and a product. But B is a product in the end and a reactant in the beginning. So this is when we call this a catalyst. It is used in the beginning and produced in the end. How would you write a reaction to the catalyst? Let's say we have a simple reaction here. A plus B makes C plus D, all right? And this happens in the existence of a catalyst. So where would you write the catalyst? If this is made with the help of catalyst, let's say E, you'll write the E on top of the arrow to represent this is a catalyst. And this is how you would write a reaction when a catalyst is involved. Now in the next video, we're going to do some more practice problems about these reaction mechanisms. Thank you for watching.